you're going to see fractions within fractions within fractions, right? So we have like fractions here on a fraction, fractions within a fraction. They look complicated, but I'm going to show you two different methods. We're going to try each one individually, and then I will kind of tell you which one I think is a little bit better. All right, so method one, we're going to start with here. Method one says you're going to add or subtract the numerator, add or subtract the denominator, and then simplify the fraction. So that means, first, if I look at number one here, x over 2 minus 1, I want to find a common denominator for the numerator. Right? I want to simplify the numerator first. What will the common denominator be? 2. So this is really going to be, if I have x squared, x over 2 minus 1, if I subtract 1, what will that fraction actually be? Minus 2 over 2, right? That's minus 1. So we found a common denominator. And now let's simplify the numerator. Right? So what would be x over 2 minus 2 over 2? How would I simplify that? Yeah, x minus 2 over 2. So that's your new numerator. We found a common denominator between the two fractions. We subtracted them. We got x minus 2 over 2. Now the denominator of that whole fraction is still x minus 2. Okay, so we haven't simplified the whole thing yet. What happens when I divide fractions? You take the top one, the numerator stays the same. So you have x minus 2 over 2, and you have to multiply by the reciprocal of the second. Well, the bottom one here is really x minus 2 over 1, right? So what would be its reciprocal? 1 over x minus 2. And what's the really nice thing that happens here if we're multiplying? The x minus 2's are going to cancel. Cancel, cancel. What are you left with? 1 over 2. So that whole fraction mess to start with is equal to 1/2. So that's method one, and that was actually a pretty nice problem for method number one. I'll show you method number two now. So method one, again, is find a common denominator of the numerator and the denominator, simplify the fraction. Method two is typically quicker, right? So it is actually going to be quicker usually. What you're going to do is you're going to find the least common denominator of every fraction, okay? And then you're going to multiply every term by your least common denominator. So, what's the denominator of x minus 4? 1, right? And then we have a 4 in the denominator and an x. What would be the least common denominator of all three of those fractions? 4x. Right? If I had to find a common denominator of all three, it would be 4x. So what you're going to do is you're going to multiply everything by 4x. You're going to multiply the x by 4x, the 4 by 4x, the left fraction by 4x, and the right fraction in the denominator by 4x. Because what's going to happen when you multiply all of these by 4x is that things are going to cancel, right? The fractions are going to go away. So here's what I mean by that. Let's start with the numerator. What is 4x times x? 4x squared. What is negative 4 times 4x? Okay. Now let's deal with the denominator. I have 4x times x over 4. What's going to happen with the 4's there? We're just dealing with the left fraction on this side. What happens with those 4's? They're going to cancel. So I have x times x, which is x squared. All right, let's deal with the fraction on the right here. I have negative 4 over x times 4x. What happens with the x's here? They cancel, so the denominators went away. And you're left with negative 4 times 4, which is negative 16. Well, now, all you have to do is factor and simplify. So how does the numerator factor? What pulls out? 4x, and you're left with x minus 4. And what would be your factored form of the denominator? X minus 4x plus 4, yeah. HC, those cancel. So you are left with 4x over x plus 4. Alright, do you see how both methods kind of work here, though? So ultimately, you can pick whatever method you want. You can find the GCS and simplify the numerator, then the denominator, or you can find the least common denominator of everything. So let's make a decision. Let's just try one. Which method do you think you want to try here? So you can either find the common denominator between the numerators and subtract those fractions, then subtract or add the denominator, and then simplify, or you can find the least common denominator of everything. What do you think is going to be easier this time? Method 1? Okay, let's try method 1. So if I did method 1, what would be the common denominator of the first fraction? Of the numerator. Let's just do the numerator. We have to multiply this by x over x, right? So that's 6x minus 5 over x. Correct? Are you okay with that? Okay. What about the denominator? It's going to be x squared. So I have to multiply the numerator and the denominator by x squared. So I'd get x, what would the fraction be? You tell me. X squared plus 5 over x squared. So now I still have a fraction over a fraction. So now I have to do another step. What do I have to do now? Two fractions I'm dividing. I have to turn it into multiplication. So I have 6x minus 5 over x, the numerator, times the reciprocal of the denominator. Okay. What's going to happen here? Anything cancel? Yeah, the x and the x squared, that gives me just 1x then in the numerator, and it doesn't seem like anything else is going to cancel off. So I'll have x times 6x minus 5 over x squared plus 5. And that will be your final answer. Now, if you wanted to, I just want to show you really quick how you would use the least common denominator method. So I'll erase just the beginning. I won't erase all the work. What would be the least common denominator of all of those numbers if you were doing that other method? X what? Squared. So you would end up multiplying everything by x squared. Now, what happens when you multiply by x squared? What do you get in the numerator? This is going to be 6x squared minus what? Minus 5x over. So there's no fraction there, right? The numerator doesn't have a fraction. What's the denominator become? X squared plus come on. 5, right? The x's squared canceled. See how this gets you a little bit faster there because you can factor out an x from the numerator. And now you're done. It saves you the step of having a fraction over a fraction and then having to multiply and then factor and cancel. If I use the least common denominator method, I get rid of the fractions from the start. So ultimately, you can use either one, but I like that way better. I guess.
If I get the least common denominator, how do you find it?
It would be like if you were adding or subtracting things. So like in this one, this denominator is a 1, an x, a 1 and an x squared. So like if you were going to find a common denominator of everything to add them up, it would have to be x squared. Does that make sense? Yeah. Maddie?
During method 1, why couldn't the x and x squared cancel out? Is it because one's common?
They did cancel off.
No, the other way. 6x minus 5 and x squared plus 5.
Because there's a plus and a minus here?
No. Is it because one's common?
Because there's a plus. Yep. You can only cancel things once they're in factored form. All right, let's try another one. 2 more. That's it. Flip over. All right, we have a bunch of fractions here. So we can simplify the numerator, fine. common denominator of the numerator, find the common denominator of the denominator, and then simplify, or we can find a least common denominator. Let's try the LCD. I think it'll make this look a little bit better. So we have a y squared, an x squared, and an x. What do you think the least common denominator is going to be here? X squared, y squared. Okay, what would be the common denominator of the numerator? So hold on, just because some people are confused by this. What's the common denominator of the numerator? Y squared, right? The common denominator down here would be x squared. Well, if I were to, because I have to combine these all somehow, I want to cancel off all the denominators. In order to do that, I have to have a y squared and an x squared in order to cancel things away if I were to add all of them up, right? So I'm going to multiply every fraction here by x squared, y squared. It seems like a lot of writing at first, but now all of those fractions are going to disappear. So it's going to look a lot nicer once you simplify everything. So what happens here with the y's in that first left fraction? The y goes away from the bottom, and you're just left with one y in the numerator. So what are you left with on the top left? 3x cubed y. All right, the second fraction there. See how the y squares are totally going to go away? Now you're done with the fractions in the numerator. You're just left with minus x to the third. All right, now let's do the denominator. The x squares here go away totally. So what's your left on the bottom? 2y cubed. And then over here, I have an x, cancels with the x squared. So you're left with minus y cubed x. Those are better. So now I have no fractions. I just have to factor and see if I can cancel anything. So what factors out of the numerator? X cubed. So I can pull an x cubed out, and then what's going to be left when you pull the x cubed out? 3y minus 1. What can I pull out of the denominator? Y cubed. Right, so I can pull y cubed out, and I'll be left with 2 minus x. Nothing cancels there, right? But it looks a little better than what we started with? Yep. So that's it. Yes.
Like when you're multiplying by x squared, y squared, by the 3x, why couldn't you cancel out the x and the 3x?
Up in this one?
Yes.
Because it's like over 1. So you can only cancel it if it would be like, if the x is in the denominator. Yeah, you can only cancel the denominators.
Oh.
Yep. All right, let's try another one. It'll get a little better. What should our LCD be here? What do you think? We have an x and an x plus 1. So it should be, well, not x plus 1, it should be x times x plus 1. Okay, you guys are overthinking this, I think. If you, here, don't write this down, just if you had that fraction, those two fractions you were subtracting them, what would be the common denominator when you would subtract them? It would be x, this is what we did the last couple of days, it would just be x times x plus 1, right? Because you'd have to multiply this by x over x, and this by x minus 1 over x minus 1, right? Does that make sense? You're doing the same thing, you're just looking at all of the denominators at one time. No? Yes? You're overthinking it, I'm telling you.
I think just the name must be
Not necessarily, but pretty much. Kind of. You're finding the least common denominator. Well, this has an x, so your least common denominator has to have an x. This has an x plus 1, so the x plus 1 has to be in your least common denominator. And I already took care of this x, so I don't have to deal with it. When I was back on this problem, there was a y, so my least common denominator had to have a y. But because this one was a y squared, the y squared kind of trumps the y because it includes the y, right? Same thing down here. I have an x squared, so my LCD has to have an x squared. Well, the x is already included in that, so that's why I use x squared y squared here.
I think the name is just confusing. Like, least common, because it makes it seem like you have to find one that's already in there.
Yeah. No, we just call it a common denominator if you want. Just a regular common denominator. There. Find a common denominator. Alright, so we're multiplying everything by x times x plus 1. Okay, so write that out. X times x plus 1. Alright, and just be careful when you simplify. Remember, we're only canceling denominators here. So the top left one is actually pretty nice. What goes away? X plus 1. So all you're left with is x, 1x, right? That's what you have after you cancel. Alright, so the second one, the x's go away. So I'm going to rewrite this out to be careful here. I'm going to have negative 1 times x plus 1, because I want to make sure that we get that negative distributed correctly. Alright, what cancels in the denominator?
The x's.
The x's. So you just have x plus 1. Now I can't cancel the x plus 1. Why? Not yet. I have to distribute. I have to have it in factored form. Because the plus is here, I cannot cancel anything. So let's go ahead and distribute the negative there, which would make this x minus x minus 1 over x plus 1. And then the x's go away. So what's your final answer?
Negative 1 over x plus 1.
Yep. Now I'm going to have you try a couple on your own, but before you do that, let's talk about the common denominators here in these two. Take a second. Just take a second, see if you can come up with what you think that common denominator you're going to multiply everything by here is going to be. You don't have to do all the work. I just want to make sure that we're understanding it on the right track. So see what you think it's going to be. All right, you can try number 7 as well, and then in like 30 seconds or so, I will check with you. Okay. So in number 6, what do you think the common denominator has to be? X, right? We get an x from here, and then x plus 4. Yep, so that's what you're going to multiply everything by. X times x plus 4. All right, did we do that okay? So if we do number 7, what do you think the common denominator has to be here? X. Yes, an x minus 1. I get an x here and an x minus 1 from there. All right, does that make sense? So go ahead and try those two. The answers are on the bottom. And then